Thank you, everybody. So we did want to give away, because we have here one Portland hodl, also known as testnet for Satoshi, because he, I don't know if anybody's heard the story, but he did mine the entire testnet 4 chain, and then he reorged himself to let other people have a chance, and then remine the entire testnet 4 chain. So, so yeah. So we have a lot of it. It actually belongs to Mara, and we have a lot of testnet 4 just from our testing activities. And for the development community, we want to be a resource and give it back. So we wanted to just give an opportunity for anybody, and this is obviously the biggest dev-heavy community in Bitcoin here, the hardcores at TABConf. And we thought maybe people would be interested in a giveaway of testnet for Bitcoin, but it doesn't seem like we have a lot of takers. Is there anyone who's actually interested? Raise your hands, show of hands. All right, we got like 5 people, sure. let's do that real quick. Anybody who does want some testnet 3 or 4 Bitcoin, please feel free to come up to me. We will arrange it offline. So I'm going to give a talk on coordinate, and later. Hey, Reese, are we up for the demo later, or are you done?
I can do the demo.
Okay, yeah. So we do have an interactive demo. There does not seem to be enough interest to support the entire testnet giveaway that we were planning. So we'll go ahead. Anybody see me offline, we'll be happy to handle that. So thank you for sticking around. I'm here to talk about the Anduro platform, and specifically coordinate, and we have a demonstration here for you for how to create assets on coordinate and use its federation-based technology to actually send premium versions of transactions at a more rapid fee rate. So before I get into the slide deck and all the boring crap, let me just describe a little bit about, oh, why am I doing this? Hold on. I was supposed to leave this up. So somebody would be very mad at me. So anybody who wants to follow, please follow and join our Discord so we can further the conversation around it. And follow us on Twitter, please. Like and subscribe. But so let's first talk about Anduro and what the aims we're trying to meet here. As Peter Todd so eloquently put, by a technical definition, you can't say that Anduro is an L2 because it does not satisfy the requirements of exiting out directly to the L1 that is Bitcoin. It is based on Bitcoin. It is a sidechain system. And what Anduro was built to do was to remedy and reconcile the problems with the other sidechains to date, specifically the 2 before the plethora of sidechains that currently exist now, using everything under the sun, Liquid and rootstock. How many people here are familiar with either or both of these? Yeah. So Liquid has some issues, as described before. It does what it does very well, and its goal was to introduce Pedersen commitments and transactions to a Bitcoin-like system. And they did this with sidechain elements, or yeah, the elements sidechain to Bitcoin. And but they implemented the federation, and the shortcoming of that model is the effectively not only do you have, as Peter so correctly pointed out, a peg that is held in the multi-sig, but you actually effectively have a cartel on block production, and that means the transactions are in no way really censorship resistant, even though they do have some masking properties. So that, you know, to me, that never really sat well as far as a usage for Liquid, even though it has some very cool features. But the other side of the coin is rootstock, which rootstock is merge mined. I don't know. So that's a question for everybody in the room. How familiar are you with the topic of merge mining? Oh, one hand. Peter Todd, thank you. All right. So let me do this first. Let me back up, because I feel y'all need to understand what merge mining is, why it's important to Anduro, and why it's important to Bitcoin. a little bit. You'll notice Layer 2 Labs here. It sponsored this this wonderful conference here. And Layer 2 Labs is of the same opinion generally that we are, is that any sidechain, any Layer 2, any other apparatus where you promote the Bitcoin ecosystem, and I won't pick the Layer 2 fight. Let me just say Meta Bitcoin or the Bitcoin ecosystem. So this is using lowercase b Bitcoin to do things, right? So it's not about the consensus on the network of uppercase b Bitcoin, the actual protocol network. Yeah, Lightning, other true L2s that fall back, yeah, they fit that mold. But what we're really trying to do here is allow you to do more with your Bitcoin. We want you to be able to use your Bitcoin for things other than just sending mere transactions in just a nominal way. We want to enable that. And we want to do it in the other important tenet of the Anduro platform. We want to do it in a way that protects Bitcoin by paying the miners, and we do this through merge mining. So I'll just back up again, and some of this on this may be a little repetitive between the two decks, but I don't think I even need to run through this one first, because y'all need to hear about merge mining. All right, so what is merge mining? So it's actually formally called auxiliary proof of work. So it's a consensus mechanism where one chain, so this is the side chain of a chain operation, it accepts valid work from the parent chain. Peter, feel free to jump in and correct me if I say anything wrong here. Yeah. So the deal with merge mining is it allows you to reuse work. So you reuse productive work of Bitcoin miners that are still constantly hashing Bitcoin. So you never actually take them away from the task of hashing Bitcoin, but you can use that work to productively mine other chains. And you do that simply by including, you have the other chain accepting Bitcoin's work as its own at a lower threshold. Right? So in order to make this happen, the parent block must contain the hash of the sidechain block, right? So it rolls up to Bitcoin in that Merkle tree, and you can have the entire instance of that sidechain rolling up and provable by the Bitcoin hash that's created in SHA-256, double SHA-256. And the sidechain must contain the valid variable proof of work. So who created merge mining? Does anybody know other than Peter? Oh, it was Peter. It was Satoshi. No. Yeah, it was actually Satoshi who created it for then a project called BitDNS, which was later reincarnated as Namecoin, which is still around, by the way, just underutilized. And yeah, he actually had the simplest and best explanation of merge mining I have still ever heard to date. He says, I think it would be possible for BitDNS to be a completely separate network from Bitcoin and separate blockchain, yet share CPU power. This was CPU. This was before GPUs, before FPGAs, before ASICs. CPU power with Bitcoin. The only overlap is to make miners can search for proof of work of both networks simultaneously. So that's mining both at once. The networks wouldn't need any coordination. Miners would subscribe to both networks in parallel. They would scan SHA such that if they get a hit, they potentially solve both at once. A solution maybe just for one of the networks that has a lower difficulty. So basically, what you do is you break off the block into two branches, and you have one branch representing the secondary sidechain and the other branch representing Bitcoin. And you only selectively show the parts of the entire Merkle tree, the given branch, to the part that cares about it. So basically, my analogy is this. So in this picture you see here, you have one image. It's a cylinder. That is a merge mine proof of work, auxiliary proof of work merge mine block. And if you look at it at Bitcoin, which Bitcoin's looking for a square, if you're looking at it from that projection, then you see a square, because it is a square. It's a valid Bitcoin block. But the same object, that same block, if you look at it from a different projection, it sees a circle, because that block is also a circle in that direction. So it's much the same way with merge mining. The only difference with merge mining, you can have n number of these, and you can tree them and nest them. So what that means is, while attempting to mine Bitcoin, you can mine a tree base, so not infinite, but pretty damn close to its logarithmic scaled version of multiple other chains, all with different attributes. So a lot has been made of this recently, both merge mining and many other ways to handle these L2s and sidechains. But most of it goes to, well, let's create a shitcoin. Let's make a shitcoin, and then we'll say, hey, we're gonna merge mine Bitcoin, and there's tons of them out there. Bob exists as a roll-up of Ethereum with its own token, and Bob has its own token, and it's able to merge mine, so it has a tenuous connection to Bitcoin because it's merge mining, but it actually exists as a roll-up of Ethereum. So it's not even Bitcoin ecosystem. So that's something, generally speaking, in our rubric, we're trying to avoid. So how does merge mine work? What does it look like? So here we have just like, this is the block header of the parent hash, right? It contains the previous Bitcoin block transaction. In this case, this actually comes from a very old diagram where it's actually talking about Namecoin. But yeah, all merge mining effectively works the same way with some minor differences. So basically, you're taking this OXPOW header and you're hashing it up and you're throwing it into an anchor to the chain. Now, I say anchor, but that is a bit of a misnomer. I don't like to use that word because it leads people to very, very, very incorrect assumptions about how the system works. So again, you see that OXPOW header and the Namecoin block, which is the merge mine sidechain, it has that same information that goes in, but into the block on the Namecoin side. But on Bitcoin side, it's just this tiny little hash. That's what represents it, and that's just to prove it was in there, and links back to the header chain properly, and you're actually using Bitcoin proof of work. So in actuality, these blocks can be produced typically with much lower difficulty than Bitcoin itself. So this is a very important aspect of merge mining. Peter, of course, mentioned that it is insecure, and it is. Reason being, a minority of hash rate on Bitcoin, the parent chain, is required to actually merge mine this side chain. So it could be 1%, could be 5%, could be 50%, whatever. But it is a subset by definition. Even if it's only even if it's full 98%, it's a subset of the total hash of Bitcoin. So it, by definition, has weaker security. Moreover, whereas all Bitcoin hash that basically could be pushed toward Bitcoin is for profitability reasons. So there's not much left on the table there. If you've got a brand new S21 and you're not mining with it, you're leaving money on the table. With side chains, with merge mine side chains, that's not the case. So they're opt-in only. So even if you only have 5 or 10% of the Bitcoin hash rate shoved at your chain, that means your marginal rate of being 51% attacked on your chain. You don't need 51% attack. If you have, you don't need 51%. If you have only 10% pointed of the Bitcoin hash rate, you only need 5% to do a 51% attack. So security assumptions are different for merge mining. So as I mentioned before, there's some common misconceptions about merge mining. And the first one is because merge mining side chains use the same algorithm as Bitcoin. So SHA-256, magic algorithm, right? So that makes it secure, right? They inherit all of Bitcoin security just because they use that. And that's not true. If 100% of Bitcoin miners merge mine all the side chain, then yes, it would inherit Bitcoin's total security. But that is that cannot be the case. So the actual security is directly proportional to the percentage merge mining. And merge mining another one is merge mining uses anchor. They anchor the sidechain blocks in Bitcoin. So at the time it's anchored, suddenly the sidechain has all of the security assurances of Bitcoin. That's another thing that you hear. And so this has kind of led to really interesting things. Like, I believe that this idea and this misconception was responsible for the entirety of Stacks, because Stacks' model is proof of transaction. And basically, they've taken this concept of anchoring to the extreme, because if all you're relying on is an anchor that is immutable data stored in the Bitcoin block to say, okay, I'm now tethered and anchored to that and that cannot be changed, if you're doing that, then it's much cheaper to just do it in a transaction, or I'll do a plug for you, Peter, use open timestamps. Do it for free. Because getting data represented on the Bitcoin blockchain, in that, so you do not have to mine in order to do that. There's no reason, there's no benefit to do that. If you want to store data on the Bitcoin blockchain, it is simpler, easier, and more effective just to purchase the space. So anchoring is not a thing. Another common misconception, since the miner is actually mining two chains, it has to split its hash rate across both of them, causing the Bitcoin global hash rate to drop. So a lot of people think that merge mining works this way, is, oh, well, if you're merge mining, you're using SHA-256, but a case in point is an example of this in modern day. You see fractal Bitcoin. How many people here are familiar with fractal Bitcoin, have heard of it recently? Made quite a few waves in the space. But it has two forms. One third of it, I believe, is dedicated to true Bitcoin merge mining. So they actually merge mine against Bitcoin in Bitcoin blocks and use valid Bitcoin proof of work. But the other 2/3 of it is actually competitive to Bitcoin mining in the SHA-256 space with a separate difficulty. And with that, they're mining SHA-256, so they're trying to draw hash away from Bitcoin actively instead of merge mining contributing to Bitcoin. While I will note, additionally, they're not doing it with any sort of native asset that is related to the Bitcoin asset at all. They have their own fractal Bitcoin token, a shitcoin. So its use of merge mining to me, while it's there and it is profitable for the near term, it's likely to be very short-lived, and I don't think it's beneficial to Bitcoin in any meaningful way. So another common misconception about merge mining. If Bitcoin sidechain is merge mined, then it is always pure one-to-one Bitcoin, and that is not true. Just as I mentioned with fractal Bitcoin, the asset has nothing to do with Bitcoin itself. It has nothing to do with it. So just because they're merge mined, same with Bob, if an asset is merge mined with Bitcoin, that has no bearing on the asset being related to Bitcoin whatsoever in price, redeemability, or anything else. So yeah, why should you care? Why do any of you care about merge mining? Merge mining creates additional fee revenue for the Bitcoin miners to help offset the waning block reward subsidy, the halvings, right? And Peter and I have disagreements on what to do about this. He's floated a tail emission as a solution to this. I would rather not see the 21 million cap fall to a tail emission. I would much rather see us have Bitcoin as the hard store of value money that we have. And the only way to do that is to raise revenue for miners to continue SHA-256 hashing. And the only way that I see that occurring is through merge mining, specifically merge mine sidechains. Any questions from the crowd on merge mining? I've got plenty of material. So seriously, does anybody have any questions? Because it's kind of a complex topic. Yes, sir. Could you please step to the mic? Thank you.
Hello. There we go. So how's this any different than, say, something like BIP 300 with like drive chains?
I'm glad you asked. So the biggest difference between this and BIP 300, this is actually inspired by BIP 300, which I've known Paul for a great many years. And what he's trying to do is accomplish the same thing through an actual soft fork of Bitcoin that makes it perfect valid Bitcoin consensus to do this and to have these secondary side chains that basically share all of the revenue with the miners. This is kind of a cheater way around it because we can do this and activate it permissionlessly in Bitcoin right now. The, of course, trade-offs is we do not have a good peg mechanism for it. So in short, I would say this is a pale attempt to try to accomplish the panacea that Paul's proposing with his BIP 300 drive chain, but to do it in a way that we do not have to ask permission to. So for those who choose to take the trade-offs and opt in, then it opens up the entire world of the ecosystem, and if the ecosystem draws good enough, then it pays the miners, and that's good for Bitcoin.
Now, does having it create a data version on the validators of the sidechain create more problems, like miners have to invest more infrastructure and data validation of the sidechain?
Well, yeah, okay, so that's another criticism of these things in general, which, you know, there are trade-offs to that, but what we're doing in Anduro specifically is we have created an API. And while the API doesn't allow for transaction selection on a sidechain, as if you were running your own node, you can get an optimized node version. So all you do is you pass it your XPub key of your wallet that you're mining against, and it goes ahead and it generates the hash trees that you need, and it passes you back a valid submit that you can mine against that includes all of the Anduro sidechains. So, you know, for an actual miner who's mining against it, typically this is pools, because if you're a solo miner, yeah. But this would be for even small pools. There's no additional incremental overhead if you use something like this. The integration's easy. You just call an API. Yeah. Thank you. Excellent question. Any others?
Hi. You mentioned rootstock. I guess they're doing merge mining. What are they not doing well, or what's the issue with their approach?
So I'm a huge fan of Sergio Lerner and what he's done over time with rootstock and merge mining. Truly pioneers with it, but merge mining exists on the EVM and only the EVM. That's all that it does, and they've tied the EVM implementation to merge mining itself. Of course, Ethereum has moved beyond proof of work, so it's not even rooted in Ethereum anymore, but that's still fine. It all works well anyway. The biggest gripe that I take is not with the actual protocol itself, is that they introduced a coin called Reddit Infrastructure Token, RIF, and that token, while strictly not necessary to perform contracts as far as I'm aware, it is touted as something that they can use, and it was basically just a fundraise for the entire operation. So in my view, any native token, just really quickly, and I'll go this in the next slide. In my view, if you want to build a true sidechain to Bitcoin, if that's your goal, it has to have several criteria. One, it has to have only Bitcoin or a Bitcoin derivative, because you can't actually have true Bitcoin, as the native asset. So the native asset is the asset you pay fees in, right? That has to be a Bitcoin derivative asset. Two, that asset needs to be freely tradable. So in other words, you know, it's not enough to have that asset on a peg-out method where, you know, you have a federation that you can go through to effectively peg it out. Yes, you should have that for those, but you need to enable other swaps, other mechanisms to do it. You cannot leave the federation being the only path. It has to be freely one-to-one tradable back to Bitcoin. And three, it needs to be a merge mine asset, because if you're building a true sidechain to Bitcoin, you can't do so without supporting the miners, which is the actual, you know, the engine behind L1 Bitcoin. So let's say you have ARC. Let's say even Lightning Network. You know, we've already decided we're not going to scale L1. That much has been made abundantly clear. So the only way that it's going to happen is either transaction fees on L1 are going to go through the roof asymptotically over time, or we're going to have to gain incremental revenue from other sources. So if all of your L2s, if they don't pay the Bitcoin blockchain, they don't pay miners to mine and secure the Bitcoin blockchain, you end up kind of upside down. Bitcoin itself is not actually about technology. That's always been my view. Satoshi didn't create any new technology when he created Bitcoin. What he created was this extraordinary alignment of incentives that every actor in the system is incentivized not to attack the system, but to secure it. And I think this is an existential risk with Bitcoin as it moves into an L2 future. if none of the other L2s on which people are actually transacting are incentivized to secure the network, then they basically go to war with the miners. So, and the incentive structure collapses in on itself. It's a very real concern for me. Of course, the only thing you can do to avoid this is a tail emission, which I'd rather not see. So, yes, sir? Well, that too. You could do demurrage with a soft fork. That's another controversial proposal. So these would be Satoshi's coins, huh? So I guess you could do that, right? That works. No. Yeah, you could also do that.
What is demurrage?
I always pronounced it demurrage. Demurrage. It actually comes from an old, it's a tax on goods at a port is where it came from. But it's actually a functional way of allowing the value of an asset to evaporate over time. So the longer an asset is held, it actually kind of radiates away, like it has kind of a half-life. This is a very loose approximation. So Freecoin was the example of that, right? Mark Friedenbach, I think, was the guy who did that. But Freecoin never caught on, but it was a demurrage-based coin. The idea, of course, thinking that you would have to spend it, otherwise it goes away. Yeah.
I mean, the thing I would explain is just say demurrage is a security tax. Demurrage is a tax go pay for the mining security, and just same way inflation is another way of doing taxation. And for a soft fork, all you would do is just make it that when you spend the coin, that's when you have to go pay the tax.
Yeah. So, and yeah, the longer it's secured, the more tax you have to pay. So it's another form of fee, but it decreases the total value that's involved in the transaction. So, is it correct, Peter, that in demurrage systems over time you actually decrease the supply? Correct.
That is a choice you can go make. The one I would propose would not decrease the total supply. It would leave the 21 million unchanged, but if you held a coin, something like, say, 0.1% per year would end up going to miners, go pay for the security of it. So over extremely long timelines, it eventually becomes worthless, but we're talking centuries.
Yeah, and the other problem is if you collect the fee when it's moved, if it does stay there forever, locked, such like as Toshi's coins, nobody ever actually pays that fee, correct? I mean, yeah, I don't know. Sorry. Yeah, exactly. Yeah, but it could come back, and if so, it would be taxed. Interesting aside. Thank you very much. So now I'll actually get into what I actually am here to talk about, and this is the first asset and the first blockchain of the Anduro platform is Coordinate. And what Coordinate is it's a fork of Bitcoin Core. This is a software fork of Bitcoin Core, because some people here, I've heard horror stories about Mara being involved forking Bitcoin. No, that's not what we're doing. We created a soft fork of Bitcoin Core just at the code level. Not a soft fork, a code fork of Bitcoin Core. So it's a version of Bitcoin Core, much like Federation Elements Federation that Liquid runs off of. It is, in fact, Bitcoin Core 26, V26 that we run off currently. We're in the process of backporting updates. But what Coordinate is basically Bitcoin with a couple of extra things. And I wanted a sidechain to make Bitcoin like the Bitcoin I was first introduced to back in 2013. Specifically, I wanted one that you could use to send people pretty reliably, cheaply, quickly, anywhere on the planet for low fees, and do some of the other stuff that people have done on Bitcoin. Although, in the world of ordinals, which have actually, I will say this, I do work for Mara, and ordinals have done quite a bit to pay the miners. And I'm all about incentivizing the miners. And I think ordinals are good for that reason. So I want to encourage the use cases of people doing it. Maybe not on Bitcoin directly. So part of this is to give an outlet for people who want to do stuff like this. Now, those of us who've been around a while have seen many asset issuances on Bitcoin. Starting in 2013, Vitalik actually did a colored coins platform called Prism. He launched a wallet, and he was trying to do colored coins on Bitcoin and innovate. And it was kind of the frustrations with that and the fact that he couldn't get anything moving, coupled with the 2013 bull run, which of course exploded transaction count, made any use cases of those completely irrelevant just by sheer monetary traffic on the network. Yeah, it made it untenable. So that era died out. And then the next era we saw was Counterparty and MadeSafe. And how many people knew this? Let me ask a question. How many of you know where Tether spawned? Know which blockchain Tether was on first? 2 of you. What's your guess? Yes, it was Omni, MadeSafe, but it was, MadeSafe, of course, was like a layer 1.5. It was a one-way peg of Bitcoin. So it actually launched initially, before it launched on Ethereum, it launched on Bitcoin. How many people? So the first NFT. Does anybody here know what the first NFT was? Huh? No, good guess. Good guess. Not also on Omni. But no, it was actually slightly predates that, Spells of Genesis. Right, which is, of course, a Bitcoin-based game. This was a game that ran on the Bitcoin blockchain. So there were all these things that have spawned entire industries in Solana and Ethereum, and they originally came from Bitcoin. And for whatever, all the reasons, and typically the Omni, like you mentioned, which is formerly Mastercoin, they died out effectively. But why did they die out again? They died out in the 2017-18 bull run for the same reason all the efforts into Prism died out. We had a bull run. Nobody gave a shit about that anymore. It was all about the monetary asset. And it took years afterward to rebuild, and we didn't see any appreciable activity until around 2020. So kind of some of the impetus of this is to create a little space for people to play in and do stuff in when that bull run happens, right? I want people to still be able to transact on Bitcoin in a Bitcoin native manner and be able to transact with Bitcoin transactions. And also I want them to be able to create assets on a Bitcoin-like system and transfer them with UTXOs, like Bitcoin, with script. That's what I wanted to do. So that's what we built. So let me go over some, actually I watched the slide deck. Hold on. Oh, I was. Dang it. All right. I know I've talked about some of this because I've just been standing up here yakking for so long. I don't even know how long. Okay, 40 minutes, fine. All right. So who's Coordinate for? It's for ordinal enthusiasts wanting native UTXO solution. Now, I'm sure all of you know how ordinals work, but it's kind of a hack, and BRC20 is way, way worse. Well, ordinals isn't kind of a hack. It is a hack. So ordinal inscriptions is literally using Taproot, and it's running a tab script, and the first argument in the tab script is false. And then it just holds carrier data after that. So it's literally hacking these the Taproot system that was created to hold these massive proofs of trees, and it's just using it to hold arbitrary data, which is usually JPEGs of some sort, or, well, not to discriminate, they're often GIFs. But yeah, I don't know if that's the best use of the resource. That is the time chain of Bitcoin. But if people choose to do it and pay fees for it, great. I say they can do it. This is another alternative I want to offer the people who want to do stuff like that. If you want to create assets and you want to move them around as tokens in a Bitcoin manner, just, hey, I want to spawn an asset on the chain and move them around as UTXOs, great. Then this is for you. So Bitcoin miners, it's really for miners too, because the whole point here is to get people transacting on it and to earn more incremental transaction fee revenue. And so this thing, it has no token other than Bitcoin itself, right? So no native token exists unless somebody seeds it with Bitcoin. There is no issuance. There is no block reward. There's only fees. But that means everything you do on the system generates fees for miners, right? Because we can't, this is all Bitcoin. We can't create Bitcoin where none exists. So this system only works if people are incentivized through whatever we offer to actually put Bitcoin on these systems, right? And then this benefits the miners by giving them a passive income stream. They get transaction fees. So Bitcoin users looking for lower fees and fast finality transactions. I'll get a little bit more into what makes the hybrid consensus special, but one of those is a federation of the two hybrid, meaning we can offer finality to a much higher degree with much higher resolution than Bitcoin itself. Bitcoin, of course, I would say it's never truly final. It's probabilistically final. Eventually, you reach a certain threshold. I mean, if you want to get technical about it, there are some checkpoints, but let's just forget about that for a second. It's probabilistically final. That is to say, you would have to undo all the work, and the odds are that that's going to happen becomes exceedingly lower and lower as time goes by. So it's also for drive chain proponents who want to, they want to use all the things that Paul's promoted for drive chains, and he's come out with 5 or 6 or 7 different drive chains that are other things that is, oh, let's Zcash only using Bitcoin. Oh, yeah, let's throw assets on this. Ethereum, likewise. So it's all of the drive chain use cases that we would use Bitcoin for. It's a way to enable them without a soft fork. It's for Lightning Network adopters who are trying to do interesting, innovative thing on the Lightning Network, but they get priced out due to the fee market. As we all know, I don't know how many of you have noticed forced closings going up a lot in the last year. Yeah. Well, it makes it very difficult to run persistent things on the Lightning Network, but fortunately what Coordinate is, it's a fork of Bitcoin Core, so it is also compatible with the Lightning Network, which again raises an interesting specter. As I said, you need a way other than the federation to peg back out, because the peg really isn't there for people to use. It's there for a backstop so that okay, I can always use this in a worst case scenario. I can peg it back out to Bitcoin. So therefore, it does retain its value of being redeemable as long as peg is in effect. So therefore, it is still worth 1 Bitcoin. What I anticipate is most people will use another mechanism to swap in and out of any other asset like this. And the best use case, I think, for Coordinate, as it is Bitcoin-based, is submarine swaps on Lightning. So you could create submarine swaps to swap back and forth between Bitcoin and this native asset and just redeem it that way, knowing that the underlying value is still 1-to-1 peg with Bitcoin. And finally, anyone sick of the RBF fee bump guessing game? So RBF is great for what Bitcoin turned out to be, because without it, you really have no assurances that your transaction's going to go through. It is just a vile UX without a full RBF in a full mempool backlog environment. It's just terrible and shouldn't exist. That being said, is we don't have the same issues, we don't have the same constraints, we don't have the same trade-offs. We're going to have a blank slate empty chain that can handle much more throughput, and it's going to have basically effectively a minimum floor on fees, because otherwise, you're not going to fill blocks initially. And even then, it's going to take a lot longer to fill up because we don't have the same trade-off constraints as keeping Bitcoin as decentralized as it is. So what's more importantly, we even allow for this other transaction type, which I'll get into in a minute, that allows for premium transactions, which is a much better UX. So I've gone over this before in my rant, but a true Bitcoin sidechain is my 3 criteria. Native asset is Bitcoin, 2-way peg to Bitcoin. This fits the bill. CBTC is the asset, coordinate Bitcoin. And native asset should be freely swappable for Bitcoin. This is not including the peg. And then Anduro hybrid proof of work consensus. So the key component to this is that it does pay the miners. You do have to pay. So let's take Liquid, for example. Liquid is effectively a cartel among the Federation members. So you're actually paying them, and they have a limited block space, and they have extremely large transactions. So I don't understand why they're so expensive. But they're so expensive because that's the price that they set as the floor. But once you introduce mining into that and allow any free actor come in, you get a bit of competition in that regard, because people can select fees for lower rates and fill up the blocks as in Bitcoin. But for the ones that can't, for the ones that are that federation, which does give you different trade-offs, like the faster finality, 80% of the fees that are garnered by the federation for the service, they actually go to the miners. And how does that happen? They're held in escrow, in effect, and anyone can spend output that the next miner that comes along to mine just takes it as additional revenue. So yeah, the Federation members are compensated for their use, but again, that's not the point. The point is to keep the network operational and send most of the fees back to the Bitcoin miners who are merge mining. So it's also Bitcoin-based. So it is a code fork of Bitcoin v26. It's UTXO compatible, backward compatible with everything that Bitcoin does currently, less the package management stuff that's been recently introduced. Yeah, it allows for the same stuff you know from script, multi-sig transactions, SegWit, Taproot, Lightning channels, and pretty much anything you could use Bitcoin for, because it, in effect, the code base is Bitcoin. So what's different about Coordinate? It's an implementation of Paul Stortz's bit asset specification, which he actually wrote this 7 years ago. I don't know if this is slightly predates drive chains or if it was the first one he did after drive chains, but it's actually a very interesting paper. I highly encourage anybody to go read it. He actually started talking about these assets back in 2017. He talks about, I forget the term he used for it, but he was describing NFTs before the term NFT existed. So it's just kind of funny to go back and look at it. But the way that it works at a high level is everything works just like Bitcoin, except for in the UTXO database, you add an extra field to each UTXO, and that field denotes what asset you're talking about, right? So instead of just having every UTXO entry be the same asset, which is Bitcoin, you have an additional field that says this UTXO represents asset X. And this enables you, this one extra little bit enables you to use Bitcoin-like transactions for any asset listed. And again, these are all on the consensus of the chain, recognized at a consensus level, which you cannot say for ordinals. Ordinals is, in a lot of ways, like Omni in the early days. Its entire existence is dependent upon outside indexers, which lend validity to the assets, right? Bitcoin doesn't know or care about ordinals. It doesn't give a shit, right? It doesn't know or care about BRC20s, right? All it knows is, oh, I see data that I can't do anything with on the chain. It's not validly enforced by Bitcoin consensus. In the case of Coordinate, it explicitly is. If you create an asset on Coordinate, it's consensus recognized. So, yeah, I'm going on. So this is actually the anatomy of how it works. We've created a bunch of different assets to a normal transaction. So a normal version 2 transaction, this is actually a version 10 transaction. And we've actually done a couple of tweaks that aren't represented here. I put a better picture in the white paper. I haven't updated the slide deck. But basically, when you create an asset, you're putting in the inputs as Bitcoin, because there's the only way to actually create this asset is to spend CBTC. So you have to spend Bitcoin in fees that are paid to miners to create an asset. After that, you have to spend CBTC to move the asset in any way, shape, or form through another different transaction version. So the native asset, the one you always pay fees in, is the Bitcoin asset. And then well, what do we do about these ordinal inscriptions? Because clearly there's some demand for that. So what we did is we created prunable blob storage. We created an entire leaf that's dedicated to storing these things, and it's completely prunable by anybody who does not want to opt in to storing these assets. You could also use a UTXO model to, because we keep the hashes of all of the assets on even the prune chain, you can use a UTXO model for any asset that you have to take your prune node, and you can prove its existence on the chain. And therefore, whatever arbitrary thing that means by owning an NFT, I don't even know. But yeah, And so it is prunable and can be maintained reasonably cheaply for node runners, or if you want to host the entire collection, you can. So this is the one side of it. The one side of it is assets. Hey, let's do Bitcoin with assets. The other side of it is let's develop a better UX for transactions. And the question was posed to me because we're doing a merge mine sidechain. Well, people want faster finality, and I said, well, shit. We're doing, and the reason that we currently chose to do a multi-sig method for actually doing our peg is because everything else that exists, I do not believe to be in a mature enough state to actually work to be an effective peg at present. That's not to say it won't. It's not to say BitVMX, BitVM2, any of the competing solutions out there will be viable. And quite frankly, the intent is to replace the existing system with them once they prove to be viable. But we never know that they will be. So in the interim, we want something that can be done permissionlessly. And as Peter gave a very, very great talk on these L2s, the one thing that he put in the title of that talk is they're all required to have a soft fork or a covenant, which currently you cannot do. So anyway, since I was reasoning, since we have to have these things anyway, then we have to have these federators involved to run the multi-sig. Why not allow them to run consensus of the chain too and grant finality to a subset of these transactions? Okay. And just, I have 5 minutes left technically, but I'm going to go over. So, all right. So, so specifically, what this allows us to do is to have an epoch-based transaction set, much like Ethereum, right? So what I've done in designing Coordinate is split it out to where we have actually 2 separate consensus mechanisms running side by side, and they each play off of one another. So what this enables from a practical user standpoint are these pre-confirmed transactions, which are specifically for high time preferences. These are transactions you want done now, you want them done fill or kill, right? And they have their own separate mempool for these transactions. Every node that receives these transactions and forwards them on, they timestamp them as soon as they receive them and forward it on. They timestamp with the local time on their computer for comparison purposes later to determine ordering and for MEV resistance. And they're accepted or rejected based on the fee rate for the block in which they're received. So in other words, they're only bidding for themselves for the block they're eligible with, right? And then after that, they die. They get evicted from the mempool immediately if they're rejected. You can resubmit, there's no penalty, but you know instantly your transaction's not gonna go through, and you can take appropriate action or not. They always take precedence over mine transactions. Again, Coordinate supports both, I call these signed and mine blocks, but the signed versions, because they have faster finality, they always take precedence over the mine version, which created a fun little problem I had to solve. And they do not allow for asset creation of tokens, but you can move tokens with pre-conf transactions. And you also bid for space via fee reserve amount specified by the first output. So this one's a little complicated. I'll get into it a little later. And you only, most importantly, you only ever have to pay the minimum fee rate to outbid anybody else who is excluded from the block. So this is a bid system, right? So instead of specifying a fee like you do in Bitcoin and say, well, here's the fee that I'm paying, right? You specify another number, and this is the maximum amount of fee that I am willing to pay. And then based on that, you they evaluate everybody's entries in the same block, and then they determine the winners who are selected and who actually make it on the chain. Everybody else gets a rejection, and those people only end up paying slightly more. One current is one Satoshi per VByte rate more than the highest transaction that was excluded. So you never overpay. So the properties of signed blocks, there's an epoch time of 1 minute. there's a capacity of a third of a mega VByte, or a third of a segment weighted, sorry, mega VByte. And so everything in coordinate is threes. These blocks come in 1/3 of the time of Bitcoin. Or actually, no, the signed blocks has a capacity of 1/3 of a Bitcoin block. And they come once a minute. And we order transactions by the order first seen. So this is done by the federators. Not only do they take an explicitly signed notice to say they will not reorder transactions, they actually publish the order in which transactions are calculated to all of the nodes, which they compare against their own internal mempool. So in other words, they could cheat, but if they did, everybody would know. So that's the best you can hope for in the MEV trade-off schema, right? Is to create a system where they're not incentivized to cheat, and if they do, everybody would be aware of it and have them publicly say they're not going to do that. Because that's the only level of trade-off that I can offer. So they only contain pre-confirmed transactions. They have to be final from the start. And they have to be signed by the quorum of the collective, and they're considered final once signed and broadcast, which takes about a minute. So in other words, you have full finality in less than a minute. Well, slightly over a minute. And the final thing is they're later encapsulated in mine blocks, paying 80% to the miner. And I'm going to skip a couple of these. All right, so this is how the MEV resistance calculation works, right? Because you have in the schema 15 federators, and they all receive transactions in a different order. So how do you determine a canonical order from that? And the answer is first you take you check for inclusion based on having seen, the majority of the members in the validator set having seen them. And then you order them. And then you take the median ranking of the orders, and then you allow them to they all reconcile to one median value, which determines the ordering rank, and then you have a series of tiebreakers, and those are offset asymmetrically. So in other words, if three have a higher rank, you add 0.1 for each of those three. So it's like 0.3 to the weighting. And if you have one that's ranked lower, you asymmetrically subtract 0.01. So this is only used for tie-breaking purposes, just to show, okay, here's the actual order these things went in with this input set. And then for final tiebreakers, which will occur eventually, the final tiebreakers end up as just by actual transaction ID. Well, first what they pay, their bid rate, and then transaction ID. And then we have normal Bitcoin mine blocks, which of course encapsulate the signed blocks. They have a block size of 1 mega VByte and a target time of 200 seconds, which is exactly a third of the time of a Bitcoin block time. So Poisson distribution of that. And in order to handle it, it was actually quite tricky, but they're first mined in a raw state, and then 3 blocks later they're reconciled. That's when it compares them against all signed blocks that have conceivably could have happened over the signed period. And they end up in the reconciled state, after which 3 blocks later they're final because the blocks are actually signed by the Federation afterward. So this is the reorg resistance in which that occurs. It looks a little artsy, but the metric on the right, it just shows that the collective has to sign. In order to mine a valid block, it must contain a valid collective signature of the block 3 blocks before it. So they cannot censor individual transactions of these blocks. The most they could do is fail to recognize an entire block, which is a much different and higher reaching model. We use, I see Hannah just walked in. Actually, it was a lot of your work that contributed to this. We actually use sparse Merkle trees for the roll-up that allow us to do the reconciliation model and then store that in an effective manner in the blockchain proofs. So this is what the actual life cycle looks like for the mine blocks. So again, these are the ones that come in every 200 seconds. So first it comes in and it's in a raw state, so it's effectively viewed as unconfirmed. And it's like that for 2 more blocks, which again, these come in 3 times as fast. So it's roughly the same as a single Bitcoin block. After that, it runs through its reconciliation in the next block. And then 3 blocks later, it must be signed by the quorum of the Federation, and you end up with a final state. So in other words, you end up with the short, high time preference transaction. You're in the final state, totally finalized in about a minute. And with normal censorship-resistant Bitcoin-style mine transaction, you are 100% finality in a Poisson distribution of 20 minutes or 2 normal Bitcoin confirmations. And that is the high level. Do we have any questions? It's easier to use than this. You don't even notice all this stuff's under the hood. So, well, I think I've used all of my time. We did have a couple of demonstrations on the Anduro platform. So we have here Nicholas Vincent with the Alice. This is the EVM chain. And he has a demo he can run for you that y'all can follow along with. And we have, of course, Portland Hoddle, if he's awake. Okay. All right, and so without further ado, how about we actually, if we'll let, because I just spent like the last hour talking about coordinate. Do you want to give the coordinate demo and show people how that works?
So in order to do a pretty easy to follow and quick demo of coordinate, like its actual practical use, I created what is typically called like an Uncle Jim node, aka a lot of people are sharing the same Bitcoin node, and each one of those represents like a wallet file that's already been loaded with some coordinate Bitcoin that can be converted into testnet Bitcoin. Again, none of this is mainnet, this is all testnet. So yeah, moving through that, basically the requirements kind of to like follow along if you actually want to do this. You have to have a laptop. Chrome or Chromium for your browser would work the best because you can actually use the web wallet or Chrome extension-based wallet. And then, yeah. So with that said, oof, I'm not doing good today. I know, it's this is, okay, thank you. Mike, can I pass today? Yes, just sit down. No, I got. Okay, let's get her done. Okay, so the first portion of this is that I'll use Chromium for the browser because that actually supports the web extension. I'll go to, I'm not doing good, man. Yeah, thanks, guys. I appreciate it. I apologize. I just feel like this is really eclectic and poorly put together, and it's actually pretty badass, but I. Sorry. It's all good. We want to see it. Okay. Here we go. Okay, I got this. Nutshell. Okay, let's go. Okay. So in essence, to get started, basically, you need to get the browser extension wallet. This was built by the Anduro team at Marathon, and I already have it, but I will. For the sake of this demo, we're going to be completely fresh, so I'm going to remove my existing wallet here. And so Anduro has been removed from Chrome, and I'll just add it in real quick. And because this is testnet Bitcoin, I am absolutely going to not deal with any of the security concerns of seed phrase backups, et cetera, because if I lose testnet Bitcoin, sorry to say, it's okay. I got plenty of them. So next, yeah, the Anduro wallet itself. You have Okay, cool. So I agree, like the terms and conditions or privacy statements on that. Please read it if you would like to do so. New account. And this is not an actual like marathon account or anything. This is literally just the name of the wallet file. So I'll name it Portland Hodl here. And then, yeah, I think I'm trying to stabilize that connection. There we go. And it'll ask you like, okay, write down your seed phrase, which obviously you should do for mainnet Bitcoin, but because we're on testnet, just gonna continue, skip the check, and no, I'm not gonna back up the recovery keys, and a password, maybe another day. So it works really well. And it also supports testnet 4, so that's one of the, like, I really like that feature. So continuing on, okay. So once you have that, I'm gonna use, may I use this as like a wedge between this cable here? Just to put pressure on it upwards. Okay, we're good. Okay, so the Anduro wallet itself, take just a moment to fetch the balances, etc. We have nothing in here right now, no BTC. This is actually testnet Bitcoin. And sure. Yeah, sure. Okay, and then, yeah, so part of the demo is, okay, so what I created here is the ability for, I'm out. This is just terrible.